Hi students, I am Sumalata. In today's class, I am going to teach you about chemical equations. This is a new lesson. Especially in today's session, you should learn about how to write a chemical equation and how to balance a chemical equation. Seeing chemical equations are coming from chemical reactions. Chemical reactions are coming from chemical changes. Let's try to observe some chemical changes around us. Formation of curd from milk, ripening of fruits, respiration procedure, digestion of food, next burning of crackers, fermentation of grapes. These are all comes under as a chemical changes. Chemical change is nothing but if any substance is going to be involved in a chemical change, that substance can't get back its original state, and the newly formed substance is completely different from the original substance. This is nothing but chemical change. Okay, these type of chemical changes from these changes we are going to write, we can call them as a chemical reactions also. So just take one example about chemical reaction of slaked lime. Calcium oxide reacting with water, they will form calcium hydroxide. Okay, this calcium hydroxide also known as a slaked lime. Here see, the substances which are going to be involved in a chemical reaction are known as the reactants. The substances formed during the chemical reaction are known as the products. This arrowhead indicates always towards products, and left side of this arrow indicates the reactants. If more than one product or more than one reactant is there, you should need to join them by using plus sign. Okay. Here this complete representation indicates about word equation of a chemical reaction. Actually, for every time writing this word equation for a chemical reaction is not the convenient way. It is the lengthy procedure and it not give accurate value or accurate information. Okay, not value, accurate information. So for getting accurate information, we should need to use chemical formulas of substances participating in that chemical reaction. What is a chemical formula? Chemical formula is nothing but it is a symbolic representation of atoms or molecules present in that particular compound. Okay, see here. So you can take chemical formulas of these substances: calcium oxide, CaO, water, H2O, and calcium hydroxide, CaOH twice. So it is the chemical equation by using their formulas. By using their formulas, we can concise the chemical equation, and it will be the more precise, and it will gives you more information. Okay, and it will be the accurate also. Okay, so it is the chemical equation of a chemical reaction. Now we will go to about how to balance a chemical reaction. See, to that one you can take one example. Propane reacting with oxygen, it will gives you carbon dioxide and water. See, this is a chemical reaction. First of all, before going to balance this reaction, why should we need to balance a chemical reaction? You have to learn about it. Why? Because in our previous classes, we already learned about law of conservation of mass. What it tells? It tells about how many number of particles participated in a chemical reaction, those many number of molecules or atoms should need to be formed. That is one thing. Another thing is how much mass is participated in a chemical reaction, that much mass will also be generated in a chemical reaction. This is another thing. That means if 10 atoms are participated, 10 atoms must and should there in the product. Okay, that is the law of conservation of mass. So that to get to satisfy that law of conservation of mass, we should need to balance a chemical equation. So here for balance a chemical reaction, what we have to do, first of all you should need to observe how many atoms are participated in reactant side and how many atoms are formed in a product side. See, carbon atoms here 3, carbon atoms there 1. Okay, 1, and hydrogen atoms here 8, there 2 only. Oxygen atoms here 2, there 1 only. So it is completely unbalanced reaction. So that we should need to balance this reaction by using simple coefficients. We should not disturb their ratios. Okay, see, first of all try to balance this carbon, number of carbon atoms here from reactant side 3, so that you should add coefficient 3 to the carbon dioxide present in the product side, or RHS means right hand side, LHS means left hand side. This LHS indicates about reactants, RHS indicates about products. Okay, so here you can add 3 to the carbon dioxide, coefficient 3 to the carbon dioxide. Then carbon dioxide in carbon dioxide, carbon atoms will be balanced from reactant side and product side. Now, how many oxygens are there in product side? See, 6 plus 1, 7 are there. Don't touch it. Now you can try to balance hydrogen atoms from reactant side and product side. From reactant side, 8 hydrogens are there, so that you can add coefficient 4 to the water molecule present in the product side. So how many hydrogens you will get? 8 hydrogens from product side. So now you can write 8 here also. Okay, now hydrogens also balanced. Now you can again calculate number of oxygen atoms. See, number of oxygen atoms are 10 from product side, reactant side only 2. So that to balance this oxygen's number, you should add coefficient 5 to the oxygen molecule present in the reactant side. So that now this one also balanced from a product side, and reactant side also it will be balanced. See, 5 2s are 10, okay, 3 2s are 6 plus 4, 10. So now it is a completely balanced equation. Okay, after adding coefficients to the substances present in the reactant side and the product side. Okay, up to this extent. Next one is what? Here one chance is there. Actually, always a balanced chemical equation having small simple numbers. But if any larger numbers are there, at that time you can able to divide that chemical equation with a common number. Once try to observe this chemical equation. I am going to see, if it is 2C3H8, okay, 10O2 plus 10 10O2, 10 molecules of oxygen, and 6 molecules of carbon dioxide, 8 molecules of H2O. See, actually this is the balanced chemical equation with the simple numbers or simple coefficients, but it is also a balanced chemical equation. Once try to observe here, how many carbon atoms? 6 carbon atoms. There also 6 carbon atoms, and here 16 hydrogen atoms. There also 16 hydrogen atoms. Oxygens 20, there also 20. It is also a balanced chemical equation, but here there is a one common factor. These all coefficients present in present with the substances from reactant side and product side, they can able to divide with a common number. That common number is 2. So if you divide with 2, all these coefficients will become, this is 5, 2 5s, 2 3s, 2 4s. Now this equation will become, this is the simplified equation of this one. Is it clear now? I think if you can't able to understand, just try to watch more times. Okay, you will get idea about it. So it is the how to balance a chemical equation. Now you can see some more examples. See, zinc reacting with hydrochloric acid, then it will form zinc chloride and hydrogen gas. Okay, here is it balanced or not, you can check. It is not balanced one. Here zinc one atom, here one, hydrogen one, but there two atoms, chlorine one, but here two. So that you have to balance number of hydrogens and so that you can balance number of hydrogens and chlorine atoms present from product side and reactant side. So here you should add coefficient 2 to the reactant side, then it will become balanced. See, now it is 2. See, now 2 hydrogens and 2 chlorines here and there. Now it is a balanced chemical equation. You can take one more example. Sodium sulfate Na2SO4 reacting with barium chloride BaCl2. It will gives you barium sulfate and sodium chloride, students. See, is it balanced or not? It's not a balanced equation. So here also 2 sodium atoms, from that side one sodium atom. Here sulfate ions 1, there also 1, barium 1, there also 1, but chlorine here 2, there 1. So that you should add coefficient 2 to the sodium chloride present from product side, then it will become balanced. Now sodium's number 2, chlorine's number will become 2. So now it's become balanced chemical equation. Here one more example you can see. Iron reacting with water, it will form Fe3O4 plus H2 gas. Here it is also not balanced chemical equation. So that for this one there 3 iron atoms, so that you can add coefficient 3 to the iron atom present in the reactant side. Now iron atoms will be balanced, but oxygens are 4, so that you can add coefficient 4 to the water molecule from reactant side. Then oxygen atoms will be balanced, but hydrogens are not balanced. And here see 8 hydrogens, so that you can add coefficient 4 to the H2 present in the product side. Now it is a balanced chemical equation here. And one more point is what? If you use states of that substance present in the chemical equation, that will be more informative. That is not in the part of balancing a chemical equation, but try to represent that one also. Okay, see, iron is present in the gaseous, sorry, not gaseous, it is the solid state. Iron is in the solid state. Water is in the aqueous state because it is coming from the moisture. And iron oxide also solid, H2 is the gas. This will give the more information about that chemical reaction. Okay, this is about how to write a chemical equation and how to balance a chemical equation. I hope you are all understand about this class. If you have any doubts, you just mention your words in comment box. Don't forget to like, share, subscribe these videos. We will meet in the next class. Bye, all of you.